Hello everyone, in this live stream we are going to focus on just exercise of a number theory. It is the last video of number theory. Of course, I'm not going to end up my videos. There is going to be several videos that follow other topics in math. And I hope the whole lessons had been understood. Now it's time to put what you have learned into practice. If you are wondering about the benefits and advantages of watching videos, just keep doing it. Here we go. Okay, the first question is, for x plus 7y is equal to 1 is given. And we will find all integer solutions. Find all integer solutions. By using Bayesian linear Diophantine equation, I will just do this in a three-step fashion. Step 1, check if this is solvable. So we have to find greatest common factor coefficient of x and y. The coefficient of x is 4 and the coefficient y is 7. The first step, we will find greatest common factor 4 and 7. So which happens to be 1, right? Because they are relatively prime numbers. So we say that greatest common factor of 4 and 7 is divisible by the result of the 4x plus 7y. So we can say it's solvable. 1 is divisible by 1. So we say it's solvable. It is solvable. Step 2, using the Euclidean algorithm to find the greatest common factor for n 7. True, we already know it's 1. We have got to go through the process so we can reverse it and finish the problem. By the way, sorry, instead of for n 7, I have to write a 7x and 13y. I'm sorry, it's my mistake. It's a 7x and 13y. Yes. Okay. So we are gonna start with the large numbers. So it is at the 13, and 13 is going to be 1 times 7 plus 6 according to Euclidean algorithm. 13 is equal to 1 times 7 and plus 6. 1 times 7 plus 6. Then remember, before I underline, 7 equals to 1 times 6 plus 1. 7 is equal to 1 times 6 plus 1. And bring them over again. And 6 is equal to 6 times 1 plus 0. Right? Yes. So we got a 0, then I stop, and just to emphasize the stuff above the 0 was a greatest common factor. And also, instead of this, we can find greatest common factor of 13 and 7 by using the Euclidean algorithm. For step 3, we are gonna take the value m and n. 7m plus 13n is equal to 1. And we found that greatest common factor 7 and 13 is 1. So can you tell me the possible values for m and n? For m, we're gonna use 2, and for n is -1, right? 7 times 2 is 14, plus 13 times -1, which happens to be -13. 14 minus -13 will be is plus 1. Okay. So m is 2. N is a negative 1. And after that, we have to find the value of k. But how can we find it? How can we find it? Here, we will take 1 and greatest common factor of 7 and 13. So 1 is equal to greatest common factor of 7 and 13. It's 1 times k. And 1 is equal to k. And after that, we will go to find x0 and y0. To find x0, we multiply km. To find y0, we are gonna take k and n. So x0 is going to be 1 times 2, which means 2. And y0 is 1 times negative 1 is going to be negative 1. So after that, we have to find the values of x and y, but we will describe value of x and y in terms of t. But how can we do this? Remember, x is equal to x0 plus, thank you, x0 plus b over d times t, which t is element of integers. And y is equal to y0 minus, it's important, a over d times t. And from here, we are gonna get, for x's, x0 is 2 plus, what is b? What is b? 13. D is greatest common factor of 7 and 13, which means 1. So 13 over 1 is 13. 13t. And y is negative 1 minus a over d, 7 over 1 is 70. So we got for x is 2 plus 13t, for y is negative 1 minus 70. Okay, glad to hear it. That sounds very nice. So, of course, where t is an integer, where t is element of integers. And let me generate 3 specific solutions pretty at one, but just to show you, I could add t is negative 1. Let's check it for t is negative 1. If t is negative 1, x is negative 11, and y is 6. So for negative 11 and 6, we can provide the equation. 7 times negative 11, negative 77, and 13 times 6 is plus 78. Negative 77 plus 78 will be 1. Okay. So we got the solution. 2 plus 13t and negative 1 minus 70, where t is element of integers. As I told you, today will be the last lesson of number theory, and after that I'm planning to continue with high school curriculum, so you can follow my videos. So please, we are in hurry. Let me erase it. And the second question, if AB is element of integers and P is a prime, and A square is congruent B square in mod P, means that when we divide A squared by P, b squared is a remainder. Then prove that p divides a minus b or p divides a plus b. Okay. It seems a bit complicated, but we'll make it easier. So all you need to do is take b squared the other side. When we take b squared the other side, we are gonna get a square minus b square is congruent 0 in mod p. It means that a square minus b square is divisible by p because the remainder is 0, is divisible. P divides a square minus b square, which means a square minus b square is difference of two squares. So instead of this, we can write a minus b times a plus b. If p divides a minus b times a plus b, we say p divides a minus b and a plus b. P divides a minus b or a plus b. That's it. We got the solution. Okay. So don't waste of time. Let's go for the next question. It's going to be question 3. If n is element of integers, so prove that 42 divides n to the power of 7 minus n. Okay. So first I would like to start by finding a prime divisors of 42. And what is divisors of 42? 42 is equal to 2 times 3 times 7, which means the first n to the power of 7 minus n must be divisible by 2, 3, and 7. Okay, and after that, we are gonna just follow simple procedures. So n to the power of 7 minus n is divisible by 2. We will get for remainder as a 0. So let me convert modular arithmetic. 7 n to the power of 7 minus n is congruent 0 in mod 2. We are gonna get 0 or not, we will check it. If we are gonna get here is 0, so it means that n to the power of 7 minus n is divisible by 2. Okay. And remember Fermat's Little theorem and Fermat theorem. N to the power of 7 is n cubed times n cubed to the power of 2 times n minus n, right? Is congruent 0 in mod 2. We have here good wishes. So 2 is a prime and the power is a prime. What is here the remainder? N cubed, right? A to the power of p is congruent 0 in mod p. So the remainder will be n cubed. N cubed times n is n to the power of 4. N to the power of 4 minus n is congruent 0 in mod 2. And n to the power of 4 is divided by 2. What is the remainder here? I will separate. So n to the power of 4 is n squared to the power of 2 minus n is congruent 0 in mod 2. Okay, n to the power of 3 times n is n to the power of 4. N cubed to the 2 is divided by 2, remainder will be itself. What is itself of the number is n cubed, right? N cubed times n is n to the power of 4. So n squared to the power of 2 is divided by 2. Remainder is n squared. N squared divided by 2, we will get remainder as a n. So n minus n, let me reduce it. N minus n is congruent 0 in mod 2. Okay. We have finished the first step. So let's give a look at the second case. N to the power of 7 minus n is divisible by 3. So n to the power of 7 minus n is congruent. Yeah, we can also write n squared as n times n. Yes, you are right. No problem. So, yes, you are right. You are talking the truth. It's good. I'm not against it. So 0 in mod 3. So instead of n to the power of 7, we will write n squared to the power of 3 times n minus n is congruent 0 in mod 3, right? It's the same. It's the same. N squared to the power of 3 divided by 3. What is the remainder? N squared, right? N squared times n minus n is congruent 0 is left over. So n squared times n cubed minus n is congruent 0 in mod 3. So we are gonna get for n cubed n minus n is 0 in mod 3. So 0 is divisible by 3. So also we are gonna pass the second case. It's okay for us. And for the next step, I think it is the easiest one. N to the power of 7 minus n is congruent 0 in mod 7. Directly, 7 and 7, they're same. So remainder, what is remainder? N minus n is congruent 0 in mod 7. Okay. We got the solution. So if n to the power of 7 minus n is divisible by 2, 3, and 7, automatically the number is divisible by 42. Okay. Okay, I will erase that. Did you get the point here? Let me take a couple of water. Okay. Any question for? If a is a number that remainder is 1 when it's divided by 3, the remainder is 2 when it's divided by 4, and the remainder is 3 when it's divided by 5. We have to find the numbers, so that's the history part. So let me write it mathematically. A is divided by 3 is remainder 1. Divided by 4, 2 is left over. Divided by 4, remainder is 3, sorry. And the last is divided by 5. Remainder is 3, and here, sorry again, it should be 2. Let me check it. Divided by 3, remainder 1. Divided by 4, remainder 2. And divided by 5, remainder is 3. Okay. To solving problem, we are gonna apply for the Chinese remainder theorem. Remember the last lesson, we have talked about it. And I hope you understood it. And I will convert this division algorithm into the modular arithmetic, such as, let me write here because we need a space for the solution. A is, yes, and A is congruent 1 in mod 3. A is congruent 2 in mod 4. And A is congruent 3 in mod 5. Okay. The first step says find least common multiple. Least common multiple of 3, 4, and 5. 3, 4, and 5. And what is least common multiple of 3, 4, and 5? It's going to be 60, right? Okay. And from here, we are trying to get K1, K2, and K3. So K1 is equal to 60 over 3, 20. K2 is equal to 60 over 4 is 15, and K3 is equal to 60 over 5 is 12. And for the second step, we are gonna take all these different K values and we will set up a new modular arithmetic. Thus, we write 20 times B1 is congruent 1 in mod 3. 15 times B2 is congruent again is 1 in mod 3. No, in mod 4. Sorry, today I had 4 lessons, so because of that, I feel myself a bit tired. And 12 times B cubed is congruent 1 in mod 5. Okay. Just tell me. 20 divided by 3, what is the remainder? Tell me the remainder. Twenty is equal to 3 times 6 plus 2, right? Remainder is 2. Or 20 is equal to 3 times 7 minus 1. And remainder is negative 1. So there are 2 remainders actually for 20 is divided by 3. And 2 and negative 1. So I will take negative 1. Why? Because the main purpose should be isolate B1. So 20 is divided by 3 will be negative 1. Negative 1 times B1 is congruent 1 in mod 3. But B1 is not isolated because we have to get rid of negative 1. How can we do this? We will multiply both sides by negative 1. So when we multiply both sides by negative 1, B1 is congruent negative 1 in mod 3. By using same methods, we will get for B2 is congruent negative 1 in mod 4. For B3, 3 in mod 5. Okay. And finally, we came the last step, which means the third one. Let me write it below. We said that the number is A. So A is equal to K1 times D1 times remainder plus K2 times D2 times and remainder plus K3 times D3 times we are gonna take this remainder. Okay, so let me write as a word what I say. And 20 times -1 times 1 plus 15 times -1 times 2 plus, and 12 times 3 times 3. So A is equal to -20 and -30 and plus 3 times 3, 9, and 12 times 9 is going to be 108, is congruent in mod 60, least common multiple of 3, 4, and 5. So -20 minus 30 will be -50, plus 108 will be 58, is congruent in mod 60. What is it? It's 58, because 58 is less than 60. If 58 is less than 60 as a remainder, we will get a 58. So there are actually infinitely solutions for A, but I will start with the smallest one. What is it? 58. And after that comes 60 times 1. 60 plus 58. What is it? 118. Can be. And after that, for the each step, we will add consecutive numbers and 60. So instead of that, we can write 58 and 60 times. Can you tell me the one letter? Let's say Q. Okay, Q plus 58, which Q is element of integers. Okay. For example, for Q, take 3. I'm sorry, it's positive integers. And for Q is 2. 60 times 2 is 120, plus 58, 178. Okay, check it. 178 divisible by 3. What is remainder? Is a 1, right? Because 3 goes 177. 178 is divisible by 4. 4 goes 176. So the remainder is 2. 120 plus 58, 178. Yes. And for 5, 178 divided by 5. 5 goes 175. So the remainder is 3. Okay, 3 is left over. By the way, we have checked our solution. That's correct. That's correct. Okay. And 5. If n is element of positive integers, n is element of positive integers, so prove that 120 divides n to the power of 5 minus 5n cubed plus 4n. Okay. So when we factorize n to the power of 5 minus 5n cubed plus 4n, we can find here the common factor. What is common factor? Is n. n times n to the power of 4 minus 5n squared plus 4 is equal to n times, when we factorize it, n to the power of 4 is n squared times n squared, and 4 is -4 times -1. And the cross production, n squared times -1 is minus n square, and n square times negative 4 is negative 4n square will be minus negative 5n square, and we got the middle term. Okay. So we write n square minus 4, n square minus 4 times n square minus 1. Okay. And we have to open it. N times n square minus 4 is difference of two squares. It will be n minus 2 times n plus 2. And n square minus 1 is n minus 1 times n plus 1 is equal to, when we order the expressions, first we will take n minus 2, after that n minus 1, after that comes n plus 1, and n plus 2. Are you aware of something here? Actually, when you look at the numbers, you can see 5 consecutive numbers, right? 5 consecutive numbers. Okay. There are 5. Yes, product of 5 consecutive integers. 5 consecutive integers. You are right, Blaise, always divisible by 5, because when we take the smallest 5 consecutive integers as a product, we will get 5 factorial, right? Because 5 factorial is as 5 times 4 times 3 times 2 times 1. And 5 factorial is going to be 120. So it means that when we take the smallest, when we take the multiplication of 5 smallest consecutive integers, we will get 120, right? So automatically 120 divides n to the power of 5 minus 5n cubed plus 4n. Okay. The product of 5 smallest integers, it is 120. So in such a way, 120 divides n to the power of 5 minus 5n cubed plus 4n. Okay. Three more questions. And question 6. How many positive divisors are there? How many positive divisors are there of 1 square minus 1 plus 2 square minus 2 plus 3 square minus 3 till 100 square minus 100. Okay. And before started, there's something else you should know. First, let me give you this theorems, because it helps us to find the answer. The first is 1 plus 2 plus 3 plus till plus n. The sum of consecutive integers. Actually, the sum of consecutive natural numbers, because start from 1. All natural numbers start from 1 and go to the plus infinity. Remember that. So their sum will be n times n plus 1 over 2. It is the first. And the second, 1 plus 3 plus 5 plus till. Remember, 2n plus 1 is a 4 more odd numbers. So the sum of odd numbers till 2n plus 1 will be just n square. It's easy to memorize. And the third one, the sum of square of natural numbers, 1 square plus 2 square plus till n square is equal to n times n plus 1 times 2n plus 1 over 6. Okay. So, and after that we can come back our question. So I will make a group. We can separate it as 1 square plus 2 square plus 3 square till plus 100 square minus 1 square, 2 square, 3 square, and minus 1 plus 2 plus 3 plus till 100. Okay. And let me simplify it. The time is limited, so let me write directly. And 100, and from the first part, we're gonna get as 100 times 101 times 201 over 6, and from the second, 100 times 101 over 2, and as a result, we write 50 times 101 times 66. The second isn't the statement under 2? No, it's just n square. Let me check it again, okay? Maybe I have a mistake here, I'm not sure. Because when we take the sum of first 3 odd numbers, 1 plus 3 plus 5 is 9. But is will give us is n square. I will check the second one again, okay? And we will get here is 50 times 101 times 66. So when we divide, actually when we find here the prime factorization, it will be 2 square times and 3 times 5 square times 11 times 10. Okay. And to find number of positive divisors, all we need to do is add each power just 1. So from here, 2 plus 1 times, from here the power is 1, 1 plus 1, and from the third number we're gonna get is 2 plus 1. From the next is 1 plus 1, and from the last one we'll get 1 plus 1 as well. So we will take product of the numbers, and which means 72. So there are 72 positive divisors of this number, the 72. Okay.